Hello, my name is Connor Tolan and welcome to my TUD Chaos Monkey project demonstration. We start here in the Git repository for the project, which contains all the files which I am submitting. The most important file in this project is the TUD Chaos Monkey Python script, which is written for Python 3. There is also an AWS Lambda function written in PowerShell, this README plus the Azure comparison README, and a setup file which I use for resizing my auto-scaling group. This README contains the necessary information to get started with this project. It includes information on how to run the TUD Chaos Monkey script. There is also an example output of the script so you know what to expect, including sample notifications sent by the script. At the very bottom, there is a link to the Azure comparison discussion, which we will get to at the end of this video. One requirement for this assignment was to have a demonstrable Git commit history. So I will open that here to show that this project had an initial commit of 8 days ago by me. All commits are by me. From here, we will go to AWS and look at the currently running instances. I have 6 running with 1 terminated. From AWS, we will go to my IDE and take a look at the Chaos Monkey script in more detail. The first thing I will do is kick off a run of the script so that it can run in the background while I give a better explanation of the code. As detailed in the README, for interactive mode, you invoke the script from the command line without any other parameters. You'll notice that only the running instances are listed. I showed that there were 6 running instances and 1 terminated instance a moment ago in AWS, but only the 6 running instances are listed due to the instant state name filter for running instances only. And these are printed out to screen. You have 6 instances running and the IDs are here. If there was 0 instances, the program would quit because there is no point continuing. The instance IDs are printed out to the console with their availability zone information. The user is asked how many instances they would like to disrupt. I will say 1 for a quick demonstration. The next question you are asked is how many times you'd like to shuffle the instance ID order. This introduces randomness to the disruption. I will answer 5 and the instance order will be shuffled and the 1 instance at the top will be disrupted. If I scroll back up here, we can see that the new instance order at the top, it was B89 and after shuffling it is now AAD. So if we scroll down, we should see that this is in fact the instance that is terminated, and it is. The timer is started so that I can track how long it takes to recover the disrupted instance in the autoscale group. I scroll down, and a rudimentary progress bar also increments with each progression of the while loop. The length of this progress bar is used to set the upper limit for the disruption test. If the length of the progress bar exceeds the configured number within the script, then the while loop exits and the test is marked as failed. So while the run continues below, I will focus on the code in the script. I will leave out the gorilla mode for now and return to that later and focus on the current interactive run. We supplied no parameters to the script, so the length of the sysargv is equal to 1, the 1 being the script name itself. The code here uses conditionals to handle which questions are asked, and the responses to these questions are stored in variables. For example, user interrupted, number of instances to disrupt, and AZ to instruct, but that's for gorilla mode. Here we see the shuffling. So depending on how many instances you want to shuffle, or if you passed in a parameter to shuffle, then random.shuffle is called on the instance IDs. And the order is printed out, which we saw in the example below. Now here we clear off some variables. Here we clear off some variables and get back the health of all the VMs in AWS using the Boto3 client describe instance status. And we print out the health before state, which we see here. The before state is. And we include the running instances in the counter for the before state, so we know our starting point, the number of instances running when we start a test. And here we see the start time is started, and we zero out instances restarted because we haven't restarted any yet.